What's up, Stellar family? It's Tyler Vanderhoeven here, and I found something kind of interesting the other day while exploring Turing signing servers, which we will talk about next week, July 10th. Be there. Not exactly sure what time it is. Stellar.org/events. Sign up for it. We're going to talk all about Turing signing servers, this idea of decentralized transaction creation within Stellar. But while exploring that and doing work on it, I found something kind of interesting around Musig, kind of like multi-signature but different, and I'd like to share it with you. So it's inside this project here called Stellar Musig by none other than our very own Johansson, a fella who's been working on lots of different Stellar projects. He wrote this very interesting M of M key aggregation. So in Stellar we have this concept of multi-sig, where you add different signers to an account and then collate the signatures of those accounts to see if it matches the threshold before a transaction gets submitted. If that all seems clear as mud, you might want to go look into that first. But if that makes sense to you, this is not that. This is actually just a single key, which you have an aggregate of lots of other keys for. So essentially you have a public key made up of lots of, or at least more than one, other keys. So like you take lots of public keys, let's say 5 public keys, and use those to make an aggregate key, which will represent a Stellar account, but for which those other 5 have to sign for. But there's no additional signers added to an account. So if we implement this, we pull in this library that Johansson has written, and you can see this config that we're going to use right here in this first. So I've got 2 little projects I built. One is a collation endpoint, and then I've got a bunch of these Musig servers. I've got 3 of them right now, 0, 1, and 2. And essentially all we're doing is taking public keys. So there's an endpoint on these, this get endpoint. So if we were to look up the get endpoint, it just delivers a key. So I've got a private key. Each of these Musig servers has a secret seed, and at the get endpoint for those, we just pop out the public key for it. So those public keys, we grab 3 of these other servers and get their public keys, put those into an array, and then that array goes into the config, and that config will produce a valid Stellar public key. But there is no singular private key attached to this, and this is important. There's no private key for this, so you don't sign this transaction with a single secret seed, secret key. You actually have to use all of these secret keys individually from these public keys that we use to generate this aggregate key. The important thing is that those secret keys don't ever generate a valid singular secret key for this aggregate public key. You only sign bit by bit a transaction for this public key. So the public key says I want to create a transaction, and then I would like a signature for that transaction, and it sends that transaction and starts to collect signatures for it from the other, in this case 3 aggregate keys. So we can see that happening down here. Well, first we just create a transaction. This is just a basic payment transaction, and then we start a loop. We loop through all of the keys, so in this case there's the 3, and we start calling the endpoints, which will do this collection of the signature. First it gets the you can see this first one is way down here around 0. It gets the commitment, and then if it's gotten the commitment, it will then go through and get a nonce, and then it will go back through and finally generate a signature, and then lastly, for the last round, the 4th round, it will get this aggregate signature. So it starts adding, it gets this transaction, it starts going around to all of the different secret keys and starts creating a valid signature for that. So with just a single Stellar account, you can start creating transactions which have valid signatures from all the other signers which were used to generate this aggregate key. So let's go ahead and run this. We accept a single parameter here, destination, which is put in the payment operation. So this is basically saying make a payment of 1 lumen to this account from this config public key, which is this aggregate key. We'll go ahead and run that, and it will generate. It sends off that transaction and pulls it from all the different endpoints and generates a signed transaction. So if you see down here, once we finally get the signature, we add that signature to the public key for the transaction that the public key just created. So if we copy that, we'll actually just go ahead and generate that again. Ta-da. And we pop this into Stellar Laboratory and we submit it. We'll notice that we have a signature. The signature is valid because this account exists and we're making a payment to that destination that we set. We'll submit that transaction, and without ever knowing a secret key, using the aggregate, we're able to generate and submit a valid transaction to the network. And we'll go ahead and look at this account real quick. There we go, successful submission. Let's look at that account. And we'll see that it only has that one signer on it. I have no idea. Nobody knows what that secret key is. We just got an aggregate from the 3 keys that were used to create it. Or generate it, rather. So that's pretty awesome. Let's look at the account that we just paid. This guy right here. Should have some 10,001 lumens. Got a payment. So we're successfully able to make payments without ever knowing a secret seed and without having to add multi-sig signers onto a Stellar account. So we're not increasing the base fee, we're not doing any additional operations, we simply have an address and we're able to start making payments from it. And for the astute observers out there, you can see that we've just made a Turing complete smart contract. We did a transaction that we created and generated, and anyone who calls this public URL with a destination can generate a valid signed transaction. However, they're not able to do anything else, right? Unless they know this, all 3 secrets from these other servers, unless they know those secrets, all they can do is get away with whatever this transaction is. And that's ultimately what the Turing signing servers is packaging, is this ability of transaction creation under very specific parameters. Obviously this one's not great because you can just make continuous payments to your own accounts, so that's not fantastic, but for a use case it's very interesting, and being able to split off actual additional signatures onto Stellar accounts and actually use this Musig functionality to create aggregate keys is quite powerful and very interesting. What I'd like to see next, though, for those of you with a little bit of free time on your hands, would be to actually fork this and make it M of N, so we can do 3 of 5 key aggregation. That's kind of the next big piece that I would need to turn this into something I could use for Turing signing servers, because like it's nice to have to require 5 of 5 or 3 of 3, but the much more powerful thing would be able to go much further beyond that and do 3 of 5, 4 of 5, 5 of 10, etc. So for the adventurous out there, I hear it's possible to do M of N key aggregation. That's the next big thing, but very interesting, very powerful. Really appreciate Johan working on this and putting it out there for others to use. Phenomenal little tool, great exploration into the actual cryptography behind Stellar. Quite enjoyed it. All of this code, by the way, is public, open source, so feel free to poke around, start digging in. Let's see if we can get that M of N. Thanks. We'll catch you later. Bye.